We take the negative log of that number, and we should get, what, 2? Okay, and you could say the pH was 2. So make sure you know what the question asks. If the question asks for the hydronium ion or the hydrogen ion, remember those are the same, we have it with X. If we ask for the pH, you must do that extra calculation. Both answers will probably show up on the exam, because it's a question of whether or not you're reading the question. Okay, so be careful with that. What was your question?
So I was wondering, when we did the actual quadratic part, we got x equals 0.1 or 0.01. With our assumption, it was 0.01 also?
It was close. So, and that comes back with our assumption. For our assumption to be 100% valid or valid enough, we have to have a 5% error. When I went through and tested it, I had a 6.7% error. That officially means it's not valid. We have to go through and do the quadratic. Turns out that error was very, very small because we end up with virtually the same number. Okay, and which is seen in that error analysis because we were only off by 2%.
And how did you do the error analysis like that?
To do the error analysis with your assumptions, what do? Anybody remember? You take your x value and you divide it by whatever you made for your assumption. So the assumption that we made was that x was much smaller than 0.15. So we do that, multiply by 100 to get a percent. If that number is bigger than 5, the assumption's invalid. Less than 5, it's valid, you're good to run. Okay? Everybody get that answer? Okay. How would we now propagate this to figure out the hydroxide ion? Okay, I need to erase some stuff here so we can see stuff.
The hydronium times hydroxide is like the constant.
Yep. So we've got two options. We know H plus equals 0.01 molar. Okay, so that's now our solved information. If we wanted the hydroxide, we could run off the equation you just suggested. H plus times OH minus equals the KW, which was 10 to the negative 14. We can now solve for the hydroxide. Okay? So that's one option. What's the other option? Involves probably a little bit more work, but in my opinion, your calculator work is easier. Convert to your pH. If pH equals 2, pH plus POH equals 14. So we could solve for the POH, do 10 to that, or sorry, the negative log of that, and we've got our answer. Sorry, no, 10 to the negative. 10 to the negative. Okay? Both options are valid. It comes down to which one you're more confident with. Okay? Questions about that? Yes?
I think I'm missing the math about how to get the pH from the molar. Is it just...
The pH from the molarity?
Yeah.
There's two relationships between H plus and OH minus. The one that we're going to, or the one that I've shown here a little bit more in detail, is that we know since we're in a water solution, H plus times OH minus concentrations equals 10 to the minus 14. That always holds true. Okay? If we know H plus, we can solve for OH minus. 10 to the minus 14, divide by that number. And we've got our answer. The other option, and it depends on your perspective, is if you've got the pH. Okay, so we can convert H plus into pH by taking the negative log. We should get 2. Okay? The relationship between the pH and the POH is pH plus POH equals 14. We can solve for the POH. The POH, we can take that back to the H plus or OH minus concentration. Okay. Which method is better? It's ultimately depending on what you can do with your calculator appropriately and what question is asked. If we asked for the POH, I would definitely push to the pH and then go to POH. Okay. If we asked for the concentration of OH minus, probably makes sense to stick with the KW. Okay? Questions about that? Okay, let's hope it's on my next slide. Yes. Okay, so ultimately all we did here was work more equilibrium problems, except now we've put it into solution. So everything we're doing in this chapter and in the next is all based on concentrations, it's molarities, no more gas stuff to worry about. Okay? And all we did was the same calculations that we did before. Okay, so what we're going to do is make it more confusing for some unknown reason. Okay? When we go through and take acetic acid and we add it to water, what kind of a solution did we make? Was it acidic or was it basic? How do you know it's acidic? You see H3O plus or H plus. Okay? If we take, decided to be mean and switch it up, not use sodium, lithium acetate, add it to water, what do we get? We get a basic solution. How do you know it's basic? You see OH minus in your products. Okay? As far as solving for the equilibriums go, everything would be fine and dandy with either of these cases. We would need to know the equilibrium constants for each of those. Okay? What we've decided to do is tabulate a bunch of equilibrium constants. Okay? So we can look up a lot of these values. However, these two equations are related to each other. And because they're related to each other, what we've decided to do is actually give them special names, okay, for each of their equilibrium constants and show that relationship between them. That way, I can report one equilibrium constant for one of those reactions, and then I can solve for the other one. Okay? So, to do that, what we end up saying, okay, so our first solution was acidic, the second one was basic. Okay? So what we go through and do here is, since we said equation 1 is looking at an acidic solution, when we define the equilibrium constant for this reaction, it's for sure going to be a capital K for equilibrium constant, but now it's capital K subscript A because I'm generating an acidic solution. Okay? What happens in equation 2? We look at the solution, it's now basic. So if I look at the equilibrium constant, I can again call it capital K, but since my solution is basic, I'll call it K sub B, or our base equilibrium constant. Okay? Why do we go through and add that? Because if I know A, I can solve B. How do I know that? What's the relationship between these two equations? Constants, good call, very true. We said this was Ka, this is Kb. What happens if I add these two equations up? We'll end up solving for H2O goes to H3O plus OH minus, or the Kw. What's the relationship between the Kw and the Ka and the Kb?
B equals 10 to the negative 14.
Kw is 10 to the negative 14. If I don't know that Kw is 10 to the negative 14, but I do know the Ka and the Kb, how do I solve for Kw? Multiply Ka and Kb. Why is that helpful? If I know Ka, I definitely know Kw, because you got that all memorized. I can now solve for the Kb. Okay? So that is an extra tier of difficulty with these. Your homework definitely asks questions about interconverting between those. Make sure that if you're looking at an acidic solution, that the equilibrium constant you're using is the Ka. If you're looking at a basic solution, the equilibrium constant that you need to use must be the Kb. If you're looking at a base solution and they give you the Ka, what do you need to do? Convert it to the Kb first, then you can go through and appropriately solve. Okay, so it's an extra tier of conversions. Yes?
So when you add up these two equations, one thing that would confuse me is that lithium.
So yeah, what's special about the lithium though?
Dissolves out.
Group 1 element, soluble, we don't have to worry about it. Officially, I didn't balance that last equation right. What else is actually over there? lithium aqueous.
And then also, since we're finished with chapter 15, do you want us to?
We're close to finish with chapter 15. I want you to.
Should we be responsible for all the material in 15? Any sections we should?
We're close to being finished with it. Some of the material I'm pushing to chapter 16 because it becomes more relevant there. So I think the only thing that we haven't covered yet, sorry, this is going to hurt your eyes if you look at it fast. So we've got 3 sections we haven't looked at yet. We will talk about those, finish those on Monday. I might post a lecture on them, but I kind of doubt it because I'm behind on everything else. But we'll finish those on Monday, and then we'll move into chapter 16. And we'll see how far we get through 16. Okay? Chapter 16 is heavy, heavy mathematics. Okay?